Alright, you guys, we are now going to tackle example 2, and this one's kind of a doozy, but that's not going to stop us from finishing this epic problem. So, the problem says find the values of x and y. Alright, so on this one, all we have to do is find x and y. So, that's pretty cool. It says c to the y, so cy is 15 centimeters technically. Y to the d, so this bad boy, is 4x plus 3 centimeters. Y to the o, yo, is 12 plus 5y centimeters, so that whole diagonal. And the other diagonal, the other side, d to the o, is 27 centimeters, and c to the d, the other entire diagonal, is 24. So be careful. This right here is pointing to the whole diagonal. I tried to make it all the same color, so you know this color goes to that. Same with this one. This goes to the whole diagonal, so be careful. Alright, so I'm going to pull up our nifty kite properties to see if this will help us to solve the problem, which I already have some of the items marked. I have the definition marked, which states it's a quadrilateral with two adjacent sides that are congruent. So these two sides are congruent and these two sides are congruent. Alright, which this one's going to kind of be like this one. We're going to use our properties and maybe some of the shapes inside of the kite to help us find some of these pieces that we're looking for. Alright, so one thing, the diagonals are perpendicular. Okay, so like before, I'm going to mark all of our perpendicular angles, so when the two diagonals intersect, bam, they form 4 right angles, which are right here. Alright, so maybe some of these triangles in here will help us to solve, again, like on the last problem. I don't know, we'll have to see. And let's see here, the other ones, it says one set of congruent opposite angles, which that may or may not help us. The diagonals bisect the angles created by the congruent sides. But again, we're kind of focusing on side lengths and diagonal lengths because everything given to us is a side, not an angle. So that might not be very helpful. And one diagonal is bisected by the other. And it's the diagonal that gets bisected is the one that intersects the two congruent angles. So this one right here, these are two congruent ones. So maybe that will help me. I don't know. We'll have to see. Alright, so looking back at here. Alright, one thing that pops out at me is that these two sides are congruent. So if these two sides are congruent, and I know that side's 15, how might I use that information to help me find what x is over here? Well, if these two are congruent, guess what? I can set these bad boys equal to each other to help me find what x is. Because if you see over here, there is a problem. Hold on, let me check one thing. I want to make sure I copied the problem down right, which I probably did, but let me double check one thing. Doesn't hurt to double check that. I didn't copy it down right. I caught myself. Guys, that should be an x right there, so I'm glad I caught myself. Jeez Louise, let me double check everything else. Oh no, don't go over there. Bad Prezi. Alright, let me make sure I copied everything down correctly. Good golly, Miss Long. Get yourself together. Okay, that's the only thing. Okay, my bad, you guys. I thought that I might have done something wrong. Okay, but anyways, let's go back to our ladybug. Stop that. Sorry, guys. Okay. So, this should say 12x. Sorry about that. Jeez. Alright, so, in order to solve for this side, eventually, I need to know what x is in order to find y, because I can't solve something with two variables in it. But, if I can use these two to help me solve for x, that will help me substitute an x value here, and then I'm left with just one variable, which is much more manageable when you're solving. Okay, so I'm going to start by setting these two sides equal to each other. So I'm going to kind of close that for now. Alright, so I'm going to do that down here. So we have our 15, or actually we'll have our 4x plus 3 equal to our 15 because the two sides are congruent. So let's solve this thing for x. So I need to get x on one side by itself. So I need to move this 3 to the other side. So how do I move this 3 to the other side? Holy hot dog, we do subtract. And 3 minus 3 cancels and turns to 0. 15 minus 3 gives me 12. So we're left with 4x equals 12. I'm going to move it up here. 4x equals 12. And then how do we move our 4 to the other side? Well, the 4 is secretly multiplying to the x, so the way we move it over is by dividing. So 4 divided by 4 cancels and turns to 1, and 12 divided by 4 equals 3. So we know that x equals 3. So yay. So that is going to help us eventually over here when we have an x and a y in the problem. Alright, so I've tackled the x. Bam, my x is solved for. But now, I must find the y value, which this 12x plus 5y is the length of the entire diagonal. So, you know, it's kind of hard right now to find the length of the whole thing, but maybe there's a way to find what this piece is, and then what this piece is. And once I know what each piece is, to find the length of the whole thing, I can add them together, which once I know the length of this diagonal, it's going to make it really easy to find out what this is. So looking here, how could we possibly find the length of this diagonal? Well, first of all, since we said that these two are congruent by one of our nifty kite properties that says that the diagonal will bisect the other diagonal, that basically intersects with your two congruent angles, which are these two. These are the two angles that would be congruent if we were solving with congruent angles. Alright, so if these two are congruent and the whole thing's 24, that means that each of these has to be 12 centimeters. So I know a lot of the different pieces, but I need to know this piece and this piece to get the whole diagonal. So do you guys see any shapes inside of my kite? That just might help me find what this piece is and this piece is. Well, like this one up here, there are these nifty triangles inside the kite that we can use Pythagorean theorem if it's a right triangle to help us find the lengths of the sides. Okay, which we're going to focus on these two triangles right here. We're going to start by focusing on this one, which honestly, it doesn't matter if I focus on this one or this one because I have the same information on both triangles. Okay, so let's look at this one up here. I'm going to call this triangle Uno 1. And this down here will be triangle 2. So let's focus on triangle 1 right now. Okay, it kind of looks like this. Alright, which this piece is 12, so I'm going to label this piece 12. And we know that this piece is 15. And this piece is a part of the diagonal that I'm desperately searching for. Okay, so this piece is going to help me find what the length of the whole diagonal is. So right now, I don't know what this one is. So, I don't know. I'm just going to call it whatever letter of the Pythagorean theorem it's going to be. Alright, so since we have a right triangle, that means we can use the Pythagorean theorem to help us solve for the sides of the triangle, just like we did up here. Okay, so we're going to be using our a squared plus b squared equals c squared, which the a and the b are the sides of the right angle, which doesn't matter which one you call a and b. I'll call this side a and this side b. Why not, right? Alright, and the side across from the right angle is our hypotenuse, which is the c. So let's set this bad boy up. So we have a squared, which is 12 squared, plus our b, which we don't know, so b squared, equals our c, which we do know, is 15 squared. Alright, let's do this thing. So 12 squared, 12 times 12 gives me 144, plus b squared equals 15 squared, which is, let me just do some side math to make sure I don't mess it up. Alright, so 15 times 15, 25, 2 at the top, 7051, so this will be 225. That's what I thought, but it doesn't hurt to check if you're second guessing yourself. Alright, so 15 squared is 225. So now, I must get the b by itself. So how do we move this 144 to the other side? Holy hot dog, you do subtract it on both sides. So I'm going to subtract my 144 on both sides, which 144 minus a 144 cancels and turns to 0. So I'm left with b squared equals 225 minus 144. Which that's going to give me, what's here? That'll give me a 1, give me 81. Alright, and how do we undo a square? Because we're so close to finding the b. You do square root that thing. You guys are so brilliant. Alright, which the square root will cancel out the squared. So we're left with b equals the square root of 81, which is 9. So this part of my triangle is 9 centimeters. Okay, so I know that this piece right here is 9 centimeters, which that's going to help me find the length of the whole diagonal, which is what I want to find eventually to help me find my y. Alright, so we have this piece solved for. Gonna branch that off. Alright, so now I need to find the larger piece, which is going to be kind of the same concept of what we just did. So let's look at triangle 2 now, which is this triangle right here. This one right here. Okay, so I'm going to draw it over here. So triangle 2, I'm going to squeeze in over here. I'm going to draw the triangle over here, so it kind of looks like this. Let's see here. Kind of like that. Whoa, sorry, that looks really bad. Let me fix that. That's really embarrassing. That's an ugly triangle. I probably should use my ruler, since I have it right here. But I'm as long as being a lazy mathematician right now, instead of a precise one. I'm sorry, you guys. I'm not going to be lazy. I'm going to use my ruler. Okay. Okay, so it looks kind of like this. This should be infinitely better. Rulers are so nifty. There we go. Alright, that looks a lot better. Sorry, guys. Alright, kind of looks like this. The piece right here is 12, which means the piece right here I'm going to label as 12 centimeters. Alright, I don't know this piece of the diagonal yet. I will in a second. Okay, which if this side is 27, that means that this side is also going to be 27. Okay, so I can label this side as 27 centimeters. Alright, and the side we're looking for is this one, which pertains to this one. And it'll be whatever A, B, and C I need in my Pythagorean theorem formula. So let me get that set up. Alright, so the A and the B are the sides of my right angle, so we have an A and a B. And the C is the side across from my 90-degree angle. So let's set this thing up, find this piece of the diagonal, which will help us find the length of the whole diagonal, which will help me eventually find y. So we're getting there, you guys. We're getting there. Okay, so I have 12 squared plus b squared equals my c, which is 27 squared. Alright, let's do this thing, which I'm going to have to do some scratch work because I don't know 27 squared off the top of my head. Alright, so we have 12 squared, which is 144, plus b squared equals 27 squared. Let's do some side work. Alright, so let's see here. 7, 7, 49, 14, 18, 0, da, da, da. Alright, we get 729. Holy hot dog, that's a big number. Let me just double check everything. It's always good to double check when you're a mathematician. 14, 4, 18, 0, 4. Yes. And then, yes, that is precisely correct. Alright, so let's solve this thing for b. So how do we bring 144 to the other side? We do, in fact, subtract the 144. Alright, which these cancel and turn to 0. 129 minus 144, that will give us a 5, and a 5, and an 8. 585. So our b squared equals 585. Alright, and then the way we undo a square is by square rooting that thing. Alright, which the square will cancel out the squared. So if with b equals the square root of 585. Now, I don't know what the square root of 585 is off the top of my head, so guess what, you guys? I get to do a factor tree, which is super exciting. So I'm going to do a little factor tree over here to figure out what the square root of 585 is. Okay? So I'm going to do that right here. Alright, well, since it ends in a 5, I definitely know that 5 will go into it, which 5 will go into it 1, 1, and 17. So guess what, you guys? That means that this won't break down because 117 is a prime number. So b is just the square root of 585. So guess what, you guys? That means that this piece of my triangle is the square root of 585. 5. Holy hot dog. That's exciting. Okay, and now using this, now that we know the length of this whole thing, that's going to help me find what this is, which I'm starting to run out of space. Okay, I'm going to grab another sheet of paper because I did not leave enough space, unfortunately. So give me 1 second to grab a sheet of paper. Okay, I'm back in a flash. Okay, so I'm going to continue on this paper. I apologize, you guys. Alright, so the length of the entire diagonal is, this piece is 9 and this piece is 585. So the length of the entire diagonal would be if we add them together. And since this is a square root, I can't really add it to it, so we're just going to leave them separate. Okay, so it's going to be the diagonal. This piece is this piece plus this piece. So it's going to be the 9 plus the square root of 585. And that will equal this bad boy right here, because that is the length of the entire diagonal. Holy hot dog. So we have a 12x plus 5y. Alright, which guess what, you guys? If you remember from the problem, we know what the x value is. It's 3. So that can substitute that in to help me solve. So the x right here that I see is going to, bam, change into a 3. So we have 9 plus 585 equals 12 times my x, which is a 3, plus 5y. Alright, and guess what, you guys? We just have to get the y by itself, and then we've solved for y. And it's okay that there's a square root. Don't let that irk you, okay? That just means that we can't combine it to the 9, and it's perfectly fine to leave your answer like this, okay? If you remember the quadratic formula, we definitely had several answers with a square root in it, so it's okay. Alright, so let's start simplifying this. So we have 9 plus the square root of 585 equals 12 times 3, which is 36, plus 5y. Alright guys, let's get the y by itself, and then we'll be done with this problem. Yeah, let's go. Alright, so I'm going to subtract 36 from both sides, because that's the opposite of a positive 36. What's the only thing that I can combine a 36 to on this side? You guys are so smart. I can only combine this to the number without the square roots because you cannot combine things that have square roots to things that don't have square roots. So be careful. So I can only combine it to this guy right here. Alright, which 36 minus 36 cancels and turns to 0. And 9 minus 36 gives me a negative 27. So we're left with, I'm going to start with my 5y, because you know me, I like my variable first. So it's going to be 5y equals negative 27 plus the square root of 585. Alright, and we just got to get this y by itself. And then guess what, you guys? It's done. Okay, which how do we move this 5 to the other side? Well, it's secretly multiplying to the y. So the opposite of multiplying is dividing. You guys are so smart. Alright, which my 5 divided by 5 cancels out and turns to 1. So we're left with y equals negative 27 plus the square root of 585 over 5. And guess what, you guys? That would be my final answer. Kind of like when we do the quadratic formula, you can never, ever, ever combine a number without a square root to a number with the square root. And you cannot divide a number without a square root into a number with the square root. So you can't be like 5 divided into 585. No. That's when the demon cats will get you. So things with square roots, leave it alone unless something else has a square root. So I know that's a really weird and awkward number, but that is going to be my final answer. So we found the y, and also in the problem we found the x. So yeah, we did it. Yay! That was awesome, you guys. That problem was a doozy, but we got through it. So way to go.